This problem is asking us to factor completely the expression 8y to the 8th plus 10y to the 4th minus 3. So in order to see that this is factorable, this is a 8th degree polynomial, but it's actually a hidden form. It's a form that we can actually recognize and do. So I'm going to rewrite this first just so you can see that it's possible to do this one. We're going to write this as 8y to the 4th quantity squared plus 10 y to the 4th minus 3. So although it isn't a, for example, quadratic, you will notice that it is 8 times something squared plus 10 times something minus 3, which means that we can use our, what I call in class, the X method in order to do this problem. So let me put this one in a blue rectangle, because that's going to say that's the form that we're going to be following. We're going to do it because it's in that form, but the way that we solve the problem is going to be like we would any kind of normal trinomial that we've seen in the past. So with an X number, or an X method, that means I need to figure out the adding number and the multiplying number. So in this context, the adding number is the coefficient to the middle term, which is 10, and the multiplying number is the product of the front and the back, which is negative 24. So now, think about it for a second. Can you think of two numbers that multiply to negative 24 and add up to 10? Hopefully you thought about it there for a moment, and you got a 12 and a negative 2. Notice 12 times negative 2 is negative 24, and 12 plus negative 2 is positive 10. So what that's going to do for us now is we can take our original and say that it was 8y to the 8th. On the back, we can see that there's a minus 3. And what the X method does for us is it allows us to split up those terms in the middle. So we had a 10y to the 4th, but the 12 and the negative 2 tell me I'm going to write it as plus 12y to the 4th minus 2y to the 4th. So it's an appropriate way of splitting up that 10y to the 4th. What do I mean by appropriate? Well, now we can factor by grouping. So in that first couple terms, you can see that there's a common 4 that we'll pull out, and a y to the 4th, which would leave you with a 2y to the 4th plus 3. And then on the second couple of terms, you'll see that their common piece is a minus sign, which leaves you with a 2y to the 4th plus 3. So overall, we have a 2y to the 4th plus 3 that's common, so we can pull that out in front and say 2y to the 4th plus 3 multiplied by the quantity 4y to the 4th minus 1. Now normally you kind of wish you would be done here, and in some cases you actually are, but you might notice now that the second part is actually a difference of squares. So we can go a little bit further, and the final answer to doing this problem completely, factoring it completely, would be to keep the 2y to the 4th plus 3, no big deal there, but then on this second part to break it down as a difference of squares, namely 2y squared plus 1 and 2y squared minus 1. And that's how you can use the X method on something that's not a quadratic necessarily, but is kind of, for lack of a better term, quadratic in form. So this would be your final answer.